this video we're going to discuss functions from a little bit broader or more general perspective than you might be used to. In particular, we're going to discuss functions that map from Rn to Rm. That's, from any combination of the reals to any combination of any other combination of the reals. In general, we don't need to map from sets of reals or subsets of the reals. We can map from any sets to any other sets, but for multivariable calculus, for the most part, we're going to stick with subsets of the reals. So that's what we're going to do in this video. So let's go back to the way you first learned about functions, and that was with a function machine. So you had your little function machine, your f of x machine, and if you had f of x, you got out something like y. From the function machine perspective, that means we have an input x. We're going to take our x and we're going to put it into our machine, and the machine does its job, and out comes y. In general, we take something which we call x, that's the argument, and then we have get some output, which is y. Normally, you put in a number 7 and you get out a number 23 or something like that. But we can have much more complicated or much more interesting inputs and outputs, and that's not at all a problem. So in this particular example, what we had was we had a function which went from R to R. So the inputs were real numbers and the outputs were real numbers. But we could just as easily have had a function which went from R to R2. That would be a function which maps the real numbers to vectors. R2 you can think of as vectors or points. Usually when we're the output of a function, we're going to think of it as a vector. So that's one thing. But we could also have functions that go from R2, say, back to R. These functions are functions that are often called scalar fields, and we could also have a function which takes in a three-dimensional vector r and outputs another three-dimensional vector r. In general, we can have a function which takes as its input any Rn and outputs Rm. Notation for this can get a little tricky just because of the complicated nature of it. And different textbooks use a variety of different methods. Some are more clever or more clear, I think, than others. For this one, we're going to use one of the more simple versions of the notation, or for this course, we're going to use the simple version of the notation. Maybe not the most clear, but it is definitely simple. So the standard notation is I have f of x is equal to y, and in this particular case, our input x and our output y. The implication here is that this is a function from R to R. If I had a different function, you probably are already slightly familiar with a function which takes in two arguments, f of x, y, and maps them to a third, z, then this one we would call a function from R2 to R. Equivalently, you could think of this as taking an input vector and outputting some value, where the vector is in R2. Now that easily extends to higher dimensions. F of x1, x2, up to x sub n equals z. This is clearly a function which maps from Rn to R. Now we don't always have to map to R, we can map to other things. So I could have something like f of t is equal to some function of x times the unit vector in x, plus some function of y times the unit vector in the y direction. This would be a function from the reals to R2. And the thing to note is that over here we have a vector equation, and this is what's described in your textbook, a vector representation of a function. I could have any combination of these. If I have f of a comma b, which maps to a plus 2b times the unit vector in I, or I hat, plus a minus b times j hat, this would be a function which maps from R2 to R2. So that gives you a brief overview of the possibilities that exist with our standard idea of a function. In the next video, you'll see how to visually represent or graph some of the possibilities that we discussed here.